So I'd like to address a common source of confusion that when trying to sample a periodic signal, or a signal that's almost periodic or semi-periodic, it's common to look at the period and then invert the period and say, well, that's the fundamental frequency, and therefore the Nyquist rate will be twice the fundamental frequency because this is omega naught. But that's not the case. Okay, that is not true. Because this is the fundamental frequency, and that's not the highest frequency contained within the signal. Remember, this is a periodic signal, so it'll have a discrete Fourier transform. But even if it wasn't strictly periodic, this is the fundamental frequency. That's the lowest frequency in the signal. It's not the highest frequency. So strictly speaking, there's an infinite number. So this is not band limited, it's band unlimited. It has an infinite bandwidth. But if we wanted to estimate the bandwidth, if we wanted to take an effective bandwidth, then we might want to say that we are taking several harmonics. So in this case, 1, 2, 3, 4, 5, 6, 7, 8 harmonics. Okay. We might want to do that to preserve 80, 90% of the energy. If we wanted 99% of the energy, we might need more than 8 harmonics. But the first harmonic is no good. So saying that the Nyquist rate is twice the inverse of the period will give you this, and this is a sine wave. Whereas what we're sampling is not a sine wave. So it wouldn't be enough to sample only at the Nyquist rate. So at the Nyquist rate means you sample only twice per period. So look at the sampling I'm sampling at the moment. Would this be enough to recreate a triangular waveform? So how many times am I sampling? 1, 2, 3 times. Oh, I missed this one here, there. So I'm sampling 1, 2, 3 times in every period. That's higher than the Nyquist rate. But if I were to reconstruct the signal using only these samples, I would reconstruct a sine wave. Because this sine wave is that sine wave. So if you want to sample a signal which is periodic or which has some kind of repeating pattern, don't look at the fundamental frequency. Look at many, many times that fundamental frequency. Look at 5, 10, 20 times the fundamental frequency. But what you want is the bandwidth, and your bandwidth will be the highest significant component that contains energy. So the fundamental might contain the most energy, but that is not going to recreate your signal, especially if it's a biological signal, like an ECG signal. What you want to recreate are the subtle variations. So your signal might look like this. If you sample taking into account only the period here, and you say, oh, the Nyquist rate or the sample rate is going to be 2 or a number greater than 2 multiplied by the reciprocal of that will lose you all of this information because you'll be sampling as if you had a sine wave. So remember, this is the fundamental period, and the fundamental period is not the same as the sampling period. Let me write that out. So T naught is not the same as the sampling period. So I hope you find that helpful.